if we look back over this topic, because tonight is our last lesson on the topic, we did the distance formula, and pretty much you can look at all the subpoints. We did all of these. We didn't specifically do proving a quadrilateral is a parallelogram using the distance formula, but all you need to do for that is if you look at the opposite sides of a quadrilateral and you show they're equal in length, and then you work out the distance of the other two sides and show that they're equal in length, you've proved it's a parallelogram with the opposite sides equal reason. And you can all use the distance formula to do that. That's something which you're capable of doing by yourself. Then we covered the gradient, and you'll notice things like parallel lines, perpendicular lines, showing something's a right angle, angle of inclination. What we do need to, I mentioned this at the end of the last lesson, but how do we show something is a parallelogram or a rhombus or something? That's something which I'll spend a bit of time with, and also something called collinearity. So how do you determine whether or not 3 points are collinear? Now, that's just a fancy way of saying like points are collinear if they are on the same straight line. So let's say we have points A, B, and C. They are collinear because they're on the same straight line. If we had points D, E, and F that looked like that, those are not collinear because they are not on the same straight line. So that's what that means. And the way we check this is if we find the gradient between A and B and the gradient between B and C, we'll find they have the same gradient. So if they have the same gradient, we know they are collinear. Now, if we had to find the gradient between D and E and the gradient between E and F, you can actually visually see they would not be equal. Therefore, D, E, and F are not collinear. So I'll go over this idea later in the lesson, but just give me a thumbs up if the idea of what it means for 3 points to be collinear makes sense to you from that explanation. Or give me a smiley face in the chat if that idea of what collinearity is means something to you. Ooh, okay, Simtanda, I lost you there. Okay. So we're going to practice this later in the lesson, so don't stress. But really, if you look at A, B, and C, they are on the same straight line. Therefore, they are collinear. D, E, and F do not fit on the same straight line. Therefore, they are not collinear. That's all I want you to know for now. And then reviewing this topic, something else that we did was the midpoint formula. So knowing how to find the midpoint of lines and line segments. We also spoke quite a lot about the angle of inclination. And how do we find the angle of inclination and the angle between two lines and so on. And then the final thing we did was the equations of straight lines. So those are the major areas that we're going to keep on going with tonight. Okay, but first of all, let's do this type of question that I haven't done yet, which is given 3 points, find the fourth point such that you form a parallelogram. So how do we do a question like this? Well, something that's important about a parallelogram is that opposite sides are equal in a parallelogram, and opposite sides are also equal. So this should be parallel, should be like this. So these two properties of a parallelogram are going to be useful for us. The other thing that's important is when they say the parallelogram A, B, C, D, we need to keep the order A, B, C. So D would have to be up here. We can't have D being down here because then I'd have to have A, D, B, C. I wouldn't be preserving the order A, B, C, D. So the order of this sequence does matter. So we're trying to show that basically, and I know this is just a rough shape, that this quadrilateral or four-sided shape is indeed a parallelogram. Well, sorry, I'm not trying to show that. We know it's a parallelogram. We're trying to find the missing point. So what I'm going to do is I'm going to go on a journey. I'm going to call this the green point. I'm going to call this the yellow point. I'm going to call this the blue point. I'm going to call this the pink point. And the pink point is like a mystery point. And that's why I've given it the coordinates x, y. Now, let's go on a journey to go from B to C. I want to know what happens to the x value when it goes from -2 to 5. So to go from -2 to 5, what has to happen to the x value? Pop it in the chat if you think you know. I have to add 7. Okay, so what I'm going to do is I'm going to say that journey was x plus 7 to go from here to here. Okay, now, let's say I'm at the green point and I go from 0 to 3. What happened to the y value to go from there to there? Pop it in the chat. What happened to the y value to go from 0 to 3? I had to add 3. Yeah, okay. Now, so we have a rule that describes the journey to go from the green to the yellow. But the good news is the journey from the green to the yellow is the same as the journey from the blue to the pink, because opposite sides are parallel and equal. So they had the same angle and they had the same distance. So how are we going to use this? Well, what I'm going to do is I'm going to write what the journey that you just told me in a little bit of an easier way. It's called transformation notation, and it just says x goes to x plus 7, y goes to y plus 3. Okay, but now here's the beauty of it. The blue point is 0, 6. I want it to go on the same journey that the green went to go to the yellow. So what I'm going to say is I'm going to say 0 plus what? What am I going to add to the 0 to make it go on the same journey that this one did to go here? I'm going to add 7. Yes, perfect. Perfect, right? Now, for the 6 to go on the same journey, I need to add 3. So what is this mystery point D? It is the point 7, 9. How wonderfully simple is that? So if they give you 3 points and they tell you the shape is a parallelogram, you simply go on a journey from one corner to the other, and you write down what that journey is, and you use those directions or that journey to help you go from another point to the point that you're trying to find. And that's literally how you find the missing point of a parallelogram. Give me a score out of 10 for how well you understood that. We're going to do 2 more examples like that, but I want to feel for how the group is feeling about that type of question. How is the group feeling? 10 out of 10, perfect understanding. 0, no understanding. Let me know in the chat what your score out of 10 is feeling like. Siamtanda, Stephen, Tapang, Silikane, Ronnie, Mulusneni, Litonolo. I want some scores, guys. Put me some scores in the chat so I know how you're feeling. Okay. Let's try this one. I'll give you a few hints, but mostly you're going to fly solo. It says A, B, C. So that's A, B, C, H. So H is going to have to be, actually, H is going to have to be probably somewhere. If I look at the angle of that line, right? If you look at how flat it is, this is also going to have to be quite flat wherever it ends up. And what I'm going to do is say I don't know what the point H is, so I'm going to make it X, Y. Now you have a choice. You can go from here to here and work out the journey and then say, okay, well, what's the journey to go from here to here? Or You could go from here to here and then use that to tell you how to go from there to there. I don't mind. You tell me, do you want me to use green and red to figure out the directions, or do you want me to use green and blue? Which one should I use? Which one are you going to use to figure out the directions? Green and blue. Okay. So how do I go from -2 to 6? What do I need to do to go from -2 to 6? I'm focusing on the journey from green to blue. What will get me from -2 to 6? So I need 2 to get back to 0. So I would need 2 to get there, and then I need another 6 to get here. So I think it will be +8. But now I need y. How do I go from 2 to 4? What am I going to need to do to y to go from 2 to 4? So I'm describing the journey. So far, I've got to go x plus 8, but now y has to go from 2 to 4, so I have to add 2. So this will be y plus 2. Okay, you've got the directions. You know how to go from here to here. But now you have to use the directions that you just wrote down to help you get there. So the good news is you can start at the point 6 minus 2. What I want to know is, what is that final point h going to be? What is that final point h going to be? Would it be okay if you use red, just a different number? It would still work out, yes. So as long as your directions will be different if you use a different combination, but you'll still get the same answer. Okay, I want me some coordinates for h. Once you put them in the chat, I will know what is going on with you. So 6 plus 8 is 14, and -2 plus 2 is 0. So the point is 14, 0. That's a -2 and that's a 6. So you know what? Actually, the point that I'm looking for is literally on the x-axis. So this point down here is just the point 14, 0, or h is just the point 14, 0. Because I took 6, I added 8. So that was, to go that distance, I went +8. And then to go up, I went up by 2, which was the same journey that went from here, +8, +2. So isn't y equal to 2? It's -2. So are you talking about this bit over here? So over here, it's in line with 6 over there, and it's in line with -2 over there. So that's why when you start at -2 and you add 2, you actually only get to 0. Okay, is that helpful, Tabang? All right, let's do another one. You do this by yourself. You have a choice. You can either go from P to S to get your directions, or you could go from P to Q. Depending on what you choose, it will affect where you start your next journey, but I want you to do this by yourself and tell me when you get R. So I'm just going to go grab some water, and then you work out what the missing point R is such that it's a parallelogram. Okay. Should I use blue to red to get my GPS coordinates, or should I go from blue to green? You tell me. I will choose the one that is the most popular. Both things will work. It's just you start at a different point when you try to figure out what R is. Okay, blue to red. So if we go from blue to red, what is the journey that I have to go on? I go from -2 to 7. So I'm actually adding 9 x units. To go from 3 to 5, I add 2. So now if I went from that one, I need to go from -3, 1 to something else. Okay, so what am I going to get for my missing point R? So I go -3 plus 9 gives me 6. And 1 plus 2, let's use a different color. 1 plus 2 gives me 3. And so this is the point 6, 3. Did anybody else get that? Give me a thumbs up if you got 6, 3 in your, or put it in the chat or give me a thumbs up, one of the two. So that's how, if they say to you something is a parallelogram, so they literally say, if this is a parallelogram, find the missing coordinate of the missing point using inspection. We can use basically this idea of, I know the journey from here to here is like that. Well, then I need to go on the same journey to get to that. These inspection questions are only, well, it's literally here, it's 2 marks. You can see it'll just be 2 marks now. All right, now I want to show you a different type of question. So I'm going to change the question now, but I am going to leave something here. So sometimes they ask, instead of if this, I'm going to scratch this out. No, it no longer happens. The question is, prove that PQRS is a parallelogram. And we have 3 different choices. The one is to use the distance formula. So show that that side is the same as that side, and that side, let me use a different one. This is the same as that side. If you show the opposite sides are equal, it's a parallelogram, but that takes quite a while. Then the other way to show something is a parallelogram is that the opposite sides are parallel, and that would use the gradient formula. So you would show that gradient is the same as that, and that gradient is the same as that. And that wouldn't take too long, but it would still take a while. The quickest way to show something is a parallelogram is to use the midpoint formula and show that the diagonals bisect each other. And the way you'll see this is if both diagonals have common midpoints. So I'm going to set you this task. This is a diagonal of this quadrilateral, which is a four-sided figure, and this is the other diagonal. I want you to find me the midpoint of the blue one, and I want you to find me the midpoint of the red one. So midpoint of PR, let me do that, midpoint of PR and midpoint of QS. And let's just see what you get, and then we'll discuss that further. So find me the midpoint of the blue one, find me the midpoint of the red one, and let's see what happens. Pop your answer in the chat when you've got them. So let's do this. Minus 2 plus 6 over 2, and then 3 plus 3 over 2 gives me the midpoint of PR, and the midpoint of QS what do you get for your midpoints? What do you guys get for your midpoints? Minus 2 plus 6 is 4. 4, so that's 2. And that is 3. So I get 2, 3 for that one. And CM Tanda agrees. Minus 3 plus 7 is 4. 4 over 2 is 2. 1 plus 5. Oh, that's good news. Okay. So this is what I was hoping, well, I kind of knew was going to happen if there were going to be a parallelogram. We have found that the diagonals have common midpoints. So now we can just say, therefore, P, Q, R, S is a parallelogram. We've proved it. Why? Because the diagonals bisect each other. So what I've shown, because this is the common midpoint 2, 3, it means that this point cuts the blue one in half. It also cuts the red one in half. Now we can kind of visually see the red one is longer than the blue one. So it's not that they're equal. It's just that this common midpoint cuts this in half. And so it is a parallelogram. So that's how you would prove, if you're given 4 points and then they say this is a quadrilateral, that's how you would prove something is a parallelogram. Give me a score out of 10 for how well you understood that. Everyone needs to vote. So 10 is like you understood it perfectly. 0 is no understanding. 5 is some understanding, but, you know, needs to improve. Let's have a look. Okay. So it seems like that was quite well understood. So here's a question here. Show that AC, so AC, notice how the order is preserved. Show AC, ER is a parallelogram. So over to you guys. And tell me done when you're done. Okay. What are the diagonals here? I think the one diagonal is going to be like this. And the other diagonal is going to be like that. So you need to find me the midpoint of EA, and you also need to find me the midpoint of RC. And I'm hoping that these will be common or the same, because then it shows it is a parallelogram. So just in the chat, when you're done doing this, just say done, and then I'll check it with you. And then it's time for a break. So -1 plus 2 over 1, and this is 1 plus -1 over 2. And then this is, sorry, that was RC that I just worked out. And then EA would be so what are we getting for this? That's gonna be a what? That's gonna be a half. That's gonna be 0. And this one over here is gonna be a half. Ooh, hold on, did I make a mistake? -2 plus, -2 plus 2. Yep, I made a mistake. So this should be -2 plus 2 over 2. And the good news about that is that then gives me what I was hoping for. So therefore, ACER is parallelogram. Why is it a parallelogram? Because the diagonals bisect. And we showed that bisect by finding this common midpoint that we have just shown is common. All right, everyone. That was a nice first half of the lesson today. And we're just going to stand up. So just take a moment for yourself to stand up. Oh, let's just stretch out. Stretch out those arms. Ew. Let's do a little twist. Oh, that felt good. Okay, let's start by rolling our shoulders back. Roll our shoulders back. Roll our shoulders forward. Okay, let's put our arms to the side. Let's just roll them around like this. We'll rotate them forward. Let's rotate them back. Okay, then let's give it a bit of a shake. So let's just, you can actually shake your wrist and shake your elbow at the same time. So shake like that. Then you can just do shake like this. It's nice and loose. Shake out the legs. Feels so good. Get all that tension out your body. And then let's just do a tricep stretch. So we do like this. And then the other side. Oh, I'm quite stiff today. Right, and then last thing we're going to do is we are going to do some jumping jacks. So make sure the space around you is clear, and we're just going to do 10 of these. 2, 6, 7, 8, 9, 10, and yeah, I feel much more relaxed, and my body feels less tense. And I hope that you are feeling the same. Let's just do a little puzzle to let our brains have a break. Looks like a bit of a Halloween puzzle or something like that. Find out what a pumpkin plus a bat times a frog or lizard, or I don't know what that is, something on a broomstick. Work out what that is for me. What are we getting? So the frog witch is 10. Looks like a very friendly witch there. And then the pumpkins are 5. Agreed. And now bats. Well, each bat is worth 1, even though the collection of bats here is 2. There's each worth 1. So now all we have to do is use BODMAS to help us figure out what this is. So what is my final answer going to be? 5 plus 1 times 10. Well, BODMAS says that I need to do my multiplication first. So I go 5 plus 10, and I get 15. All right, everyone. So that was our little puzzle for today. I'll go and maybe try and find a few more riddles. I know you quite enjoyed the riddles, but hopefully that was a little bit of fun for you as well. Okay, so let's have a look at some other types of questions. Okay. I want to show that this thing is a rhombus. Now, if you want to show something is a rhombus, you have to show that it's a parallelogram, and then you need to show a little bit extra. So in order to show something is a parallelogram, you have to show that the diagonals bisect. To show it's a rhombus, you have to show that the diagonals bisect at 90. That's the one way of doing it. There are other ways of doing it, but by far the quickest and easiest way is to work with the diagonals and show somehow that these diagonals meet at 90. But before we can do that, I want you to find me the midpoint of BD and find me the midpoint of AC. And then let's just check that it's a parallelogram before we can even show that it is a rhombus. Okay, so find me the midpoint of BD and AC. And basically, it's the point M that we're trying to, well, is it? I don't know. We have to check. Ugh. What are you guys getting for your midpoints? What are you guys getting for your midpoints? For the first one, I get minus 1, 1. Tongue agrees with me. What about AC? What did you get for that? I'm pretty confident it should be the same. So minus 2 over 2 is minus 1. That is 2 over 2, which is 1. Yes. Okay. Good news is that we know this is a parallelogram. Now, how are we going to prove that the diagonals meet each other at 90? We talked about this a little bit in a previous lesson, but what's the quickest way to show that two lines are perpendicular? What formula should I use? I think I need to use the gradient formula. So I want you to find me the gradient of AC, and I want you to also find me the gradient of BD. So everyone, go ahead, find me the gradient of each of those two diagonals, and then tell me what you notice about the gradients. What do you notice about the gradients? So we know what the gradient formula is. So 7 minus minus 5 over 2 minus minus 4, which gives me 12 over 6, which is 2. And for BD, I'm going to go, oh wait, not minus 9. I almost made a mistake there. 5 minus minus 3 over minus 9 minus 7. So that's going to be 8, and that is going to be minus 16, which simplifies to minus 1 over 2. Now, they are not the same. They are definitely not the same. But what do you notice about them? What do you notice about them? So if you multiply the gradient of AC by the gradient of BD, which is just 2 times minus a half, you get minus 1. And therefore, we know that AC is perpendicular to BD. Now, this is fantastic news because you now have shown that the diagonals cut each other in half, and they do so at 90 degrees. So when we can say ABCD is a rhombus because the diagonals bisect at 90 degrees. So the bisecting part comes from the midpoint formula, and the 90-degree part comes from the gradient formula. And that's how you prove something is a rhombus. Okay, so it wasn't too bad. It's just a little extra bit. So let's just do one. I want to do one of these, and then I'll do collinearity, and then we call it a day. So another type of question that comes up sometimes is something called intersection points. So this says the diagram shows the lines 3x plus 2y equals minus 12. We'll call that one this one here. And then we'll call that the green one there. And it says use the diagram to solve the simultaneous equation, and it just lists the yellow and green one again. Now, when you solve simultaneously for two straight lines, the intersection point of those two straight lines is the simultaneous solution to both of those. So when we solve this using algebra, or if we see where two lines meet, we know that point is the simultaneous solution to those two equations. Which of the four options do you think is correct and represents this blue dot here? Is it A, B, C, or D? Let's have a look. Now, it's a little bit small. You may not see here, but that is a -2. And that is a -3. So what is the coordinate of this blue dot? It's actually going to be B. And just to show you that this is true, because this is more from simultaneous equations earlier in the year, but if I wanted to solve this set of simultaneous equations, the easiest way is to sub the easy one into the hard one. So we would go 3x plus 2 times y equals -12, but y would come from the easy equation. We would then multiply the 2 into the brackets and get that. We would then get that, which leaves us with 5x is -10 and x is -2. And this is great news because look at what we got over here. We got x is -2. So the algebra and the graph are doing the same story. How do we find y? Well, we have the equation y equals x minus 1. We know x is -2, so take away 1. We get -3. And that's exactly what the graphic showed here. Okay, so just be aware that intersection points are really just the simultaneous solution to two straight line equations. Last thing I want to do tonight is what does it mean for something to be collinear? So let me give you 3 points. The points are 1, 1, 3, 5, and 6, 6. Are these 3 points collinear? Well, in order to know if they're collinear, the gradient between A and B and the gradient between B and C should be the same. So you work out the gradient and you tell me, are the points A, B, and C collinear? Do they fall on the same straight line? Or do some of them fall on the line and some of them not fall on the line? Or do maybe all of them, 2 of them off the line? I don't know. I don't know what the answer is yet. So you work out the gradient between those two, and then you tell me. So what's the gradient? 5 minus 1 over 3 minus 1. Are these points collinear? Yes or no? I want you to put your answers in the chat. Okay, so no, they're not. And the reason is AB's gradient is not equal to BC's gradient. If something is on the same straight line, the gradient between this one and this one will be the same as the gradient between the red and the green one. But when that doesn't happen, they cannot be on the same straight line. Okay, let's try another one. Let me do so we'll call this D. And this F, I'll make this. Are these 3 points collinear? I want you to take them. Are D, E, and F collinear? You work that out for me. And tell me yes or no in the chat. So 5 minus 3 is 2. 4 minus 2 is 2. And then over here, 9 minus 5 is 4. 8 minus 4 is 4. So both of these seem to have the gradient. Well, not seem to. They do have the gradient 1. So is D, E, and F collinear? Do the points fall on the same line? Well, yes, it is collinear. And it's because the gradient of DE equals the gradient of EF. And in fact, for bonus points, what is the equation of this line? It's just actually y equals x plus 1. Can you see how to get from x to y, I just add 1? So this is just the straight line, y equals x plus 1. And all these points will fall on the line x plus 1. And so they are, in fact, collinear. Just give me a score out of 10 for how you feel about collinearity. Do you understand what collinearity means and how to check whether or not 3 points are collinear? Let me know how you are feeling. Give a score out of 10. That seems to be the easiest way for us all to share ideas. Okay, fantastic. All right.